Let me show you how to solve problems with efficiency. This is our big formula here, right? It's really just two formulas. I was too lazy to write it as two formulas, but efficiency is work output divided by input, or power output divided by power input. So this is output, right? This is the input, okay? Typically efficiencies are numbers between 0 and 1, okay? But you could express it as a percent, okay? So let's suppose we have a furnace. Typical furnaces that have a flue that goes through the roof of the house are 85% efficient, okay? And that's what you'd see. That's what it's very common, right? But we would say that the efficiency is 0.85 for that, okay? And the question here, is what's going on? Well, I can draw a little diagram. This is called a Sankey diagram, right? If we have 100 units of heat coming in, this is natural gas that we're burning, probably, right? So that's the potential energy in the natural gas, right? Then we can draw like a little arrow like that. And we're trying to make that, woo, that's not very straight, right? And then we can draw the rest of this like this, right? This thing is waste, right? This is probably what goes up the chimney, so this is wasted, right? And there's 15 units wasted, right? And 85 units go heat in the house, right? Okay. This is actually called a Sankey diagram, and you see them a lot, right? So the input is our natural gas energy that we put in, right? 15 units are wasted. This is probably heat that goes up the flue. Up the flue. How do you spell the flue? Is it just F-L-U? Is it E? I don't know. Okay, and then this is the heat that goes into the house. Okay, and what's interesting here is that these furnaces, that 15% is not totally wasted. It does things like carry carbon monoxide out of the house, and to make them more efficient than 85%, it turns out for furnaces, you have to have a fan to blow it out, and they blow it out like sideways. So one thing you could do tonight is check your house and see if the exhaust gases from your furnace go up through a hole in the roof, or do they go out through the side. If it goes out through the side, it's probably more than 85% efficient. New furnaces are like that. Okay, let me just show you. Let's do an example problem here for you. It's a pretty simple concept, right? A 1 horsepower motor, right? So this is the output. Consumes, that's language for input. Okay, that many watts of power. So this is like an electric motor, right? Okay, and so all we have to do really is convert horsepower to watts, right? So the power input or power output, right, is 745.7 watts, because that's what a horsepower is in watts, right? And the power input is 815 watts, right? And so what our efficiency is, output divided by input, so this divided by that, right? 5.7 watts divided by 815 watts. Let's do that on the calculator. 745.7 divided by 815, and that is 0.91. I'll just round it to 5, and that's our efficiency. Scientists will tend to leave it like that, and then journalists will write it this way, right? The rest of us understand percent, right? 91.5% efficient. Electric motors are generally fabulously efficient, right? And then the question is, where does the other 8.5% of the energy go? And ultimately, it just turns into heat, right? The electric motors get warm, and that's energy that's not used in lifting elevators or speeding up cars or whatever the thing's supposed to do. Let's hit the right arrow here and just look at a elaborate Sankey diagram for an automobile, right? Okay, so here's apparently a Ford Explorer or something like that, right? 100 units of gasoline, that's energy input, right? And you always do them like 100 units, right? And 33 units are wasted out the exhaust, right? Probably heat, right? Unburned fuel. I'm just guessing. I really don't know. But you know, these cars have little catalytic converters underneath here that burn up the fuel that doesn't burn inside the cylinder or the pistons, right? And then 29 units is lost through cylinder cooling. These things ultimately are like heat engines, and they actually, it's intrinsic to them that they waste heat. Okay, so there's some lost, right? Just pumping the air, you have to filter the air and get it into the car, right? So that's 6 units there. Piston ring friction, other engine friction, right? And then you have 25 units usable, right? Usable horsepower, right? And then if you turn on the headlights or whatever, right, or run the air conditioner, that takes power that could be propelling the car. So yeah, less than 25% efficient. So why do we use internal combustion engines? Well, I guess, I mean, you know, if you think about it, a gallon of gasoline, which weighs less than 8 pounds, can make my car go like 45 miles. So, I mean, to me, that's, even though it's terribly inefficient, that's an amazing thing. So, anyway, hope that helps.